Let us come to the rule 3 now. In this, q is equal to x raised to power m, or some polynomial in x, right? Q might be equal to x raised to power m plus x raised to power m minus 1 up to so on x plus 1, okay, multiplied by some constants, okay, a1, an, am minus 1, here a1 and a naught, okay. This sort of polynomial can be there, right? So I'm gonna tell you in this video how we are going to solve such particular integral, okay. So we are discussing 5 particular cases of 5 standard cases of particular integral. So this is the case when q would be equal to, first case was when q was equal to ex. In second case we saw how to deal with the particular integral where q is equal to sine ax or cos ax. In this we replaced d by a, and in this we replaced d square by minus a square. So now you see what we are going to do in the third rule, okay, in third case of particular integral, right? So in this we are going to use binomial theorem, okay. Firstly we do what, 1 by fd, we are going to change this into the this form, right? 1 plus gd, okay, 1 plus gd. We are going to take something common from here and we want this form, so that we can write it as 1 plus gd inverse, right? Then we will be applying binomial theorem on this. We know 1 plus x minus 1 is equal to 1 minus x plus x square minus x cube up to so on, or in case of this it is equal to 1 plus x square plus x square, 1 plus x square plus x cube up to so on, okay. So see, I'll giving you an example, okay, to, okay, let us understand it better with the help of an example, right? Okay, so let us take an example. Evaluate 1 over d square plus 2d minus 3 x square, okay. So we are going to evaluate this particular integral. So you see here, particular integral is d square plus 2d minus 3 x square, okay. So you do what, firstly as I told you, we are going to change this operator in this form, right? We are going to change this into this form, right? So for that we will have to write this operator in the ascending powers of d, okay. So write this in this way, 2d plus d square x square. Now take this common, so that we have 1 in the place of first term, minus 3 outside, 1 plus 2d plus d square divided by minus 3 x square. It can be written as minus 1 by 3, okay, 1 minus 2d plus d square divided by 3, okay. 3 negative sign of c has been taken into the center, minus 1. x square. Now apply binomial theorem here. Expansion through the binomial theorem, we get it can be written as 1 plus 2d plus d square 3 plus 2d plus d square divided by 3 whole square plus 2d plus d square 3 whole cube up to so on. Okay, by expansion by binomial theorem. Okay, at the last when expansion is done, you will have to write x square here. Okay, x square, why? Because q is equal to x square in this case. So this is equal to minus 1 by 3 okay, minus 1 by 3 and 1 plus 1 upon, I'm sorry, what was that? Okay, so now take this, you do what? Take this x square inside. Okay, so taking it inside, we get x square here plus 2d. Before writing this, let me tell you one thing. Okay, if you differentiate x square one time, you get 2x. Okay, if you differentiate x square two time, you get 2 only. But if you differentiate x square 3 time, you get 0, right? So this is the very important thing in this, because whenever the power of d rises, okay, whenever the power of d rises, the differentiation becomes 0. So in this way, higher term in this case would be becoming 0, right? So we can also write this in this form. Okay, 1 plus 2d divided by 3 plus d square divided by 3 plus, from here we are going to get 4d square by 9 plus 4d cube by 9 plus d4 by 9. Okay, or next, so see, so we are not going to write this. Why we are not going to write this? Because when you are going to take this x square inside, okay, if x square is taken inside, this would be 0 obviously. Also d4 x square would be also 0, d5 x square would be also 0. All the higher differentiation of x square would be 0. So we are not going to write this, because for this differentiation is equal to 0. So you see here also this term would be having minimum degree of d would be 3 here. Okay, it would be 8 d cube divided by 27. This is the minimum degree, minimum order of this thing, right? So highest would be 6. So in this term, degree of d would be varying from 3 to 6. Okay, since differentiation of x square with respect to, okay, with d cube is equal to 0, and higher with the higher term it is also equal to 0. So we will have to we can avoid these sort of terms which are higher in degree, higher than 3. Okay, x square, right? Let me tell you one more thing, one more time, okay? इस what is happening here, यहाँ पे हो क्या रहा है, देखिए डी एक्स स्क्र का डिफ्रेंशिएशन कितना है, 2x है, डी स्क्र एक्स स्क्र का डिफ्रेंशिएशन कितना है, 2 आएगा, ओके? अगर एक बार फिर से इसको डिफ्रेंशिएट करोगे तो इट वुड बी 0, राइट? और इसका और एक बार फिर से D4 फाइंड आउट करोगे, इट वुड बी 0, D5 भी 0 हो जाएगा, सब कुछ इसके बाद जितनी भी हायर डिफ्रेंशिएशन आएगी सारा 0 हो जाएगा, ठीक है? तो देखो जब आप एक्स स्क्र को अंदर मल्टीप्लाई करोगे तो ये कितना हो जाएगा, x हो जाएगा, एक्स स्क्र हो जाएगा, और यहाँ पे एक्स स्क्र लिखोगे आप, ओके? और यहाँ पे एक्स स्क्र लिखोगे, यहाँ पे एक्स स्क्र लिखोगे, यहाँ पे भी एक्स स्क्र आएगा, पर ये कितना हो जाएगा, 0 हो जाएगा, बिकॉज डी क्यूब एक्स स्क्र डिफरेंशिएशन ऑफ एक्स स्क्र 3 टाइम इज 0, और ये भी 0 हो जाएगा। अब देखिए इस टर्म की, ये वाली टर्म हम यहाँ पे क्यों नहीं लिख रहे हैं, बिकॉज इसकी मिनिमम डिग्री कितनी है, 3 है, इसकी डिग्री वेरी करेगी 3 से 6 तक, और मिनिमम डिग्री कितनी होगी, 3 होगी। अब मिनिमम डिग्री के लिए x की डिफरेंशिएशन 0 हो रही, तो हायर टर्म के लिए 0 होगी, और इसके बाद और हायर हो जाएगी टर्म, 4 आ जाएगा, तो उसकी मिनिमम डिग्री 4 होगी, और 4 के लिए भी एक्स स्क्र की डिफरेंशिएशन कितनी हो जाएगी, 0 हो जाएगी। तो इसके बाद जितने भी पावर आएंगे उसके लिए सबके लिए एक्स स्क्र की डिफरेंशिएशन कितनी हो जाएगी, 0 हो जाएगी। तो नॉन ज़ीरो किसके लिए होंगी, सिर्फ d के लिए, डी स्क्र के लिए ओनली, बाकी हर केस में differentiation would be 0. So these are the only 3 terms which we are going to consider. Rest of the things, rest of the terms are 0. So we are we are only going to take it up to 4d square by 9. Okay. So it is equal to minus 1 over 3 x square plus 2d x 3 plus d square x square, it is x square, okay, 3 plus 4d square x square 3 plus 0 0 0, okay, okay. So it is equal to minus 1 by 3 x square plus 2 to 4 4x by 3 plus 2 by 3, okay, it is 2, right, plus 8 by 3, 8 by 9, 8 by 9, okay, this only. Now 1 by 3 x square plus 4x by 3 plus it would be 14, okay, plus 14 by 9, right? So this is your particular integral in this case. Now I'm just giving you an exercise, okay? You just solve it out, evaluate. Evaluate 1 upon d square plus 2d minus 3 into x square plus x plus 1, okay, and write the answer in comment section. Now one more problem on rule 3, okay. So here we are given y double dash minus y single dash plus 4y is equal to x square plus sin 2x, okay, right? So it could be written, it could be also written double derivative of y with respect to x minus single derivative of y with respect to x plus 4y equal to x square plus sin 2x, right? So firstly, symbolic form is d square minus d plus 4 x square plus sine 2x. Okay. So, I think you will be able to find out its complementary solution, complementary function easily. So roots of this equation would be auxiliary equation 2 and 2 repeated roots. Therefore yc would be equal to c1 e raised to power 2x plus c2 x e raised to power 2x. So this is the complementary solution. Let us come to the particular integral now. Particular integral is equal to 1 over d square minus 4d plus 4 x square plus sine 2 x. Okay, so you can take 4 outside now, 4 common, and you will be having inside 1 plus d square minus 4d divided by 4. Okay, x square plus sine 2 x. Oh sorry, firstly you separate these two things, right? Because this would be solved with the help of rule 3 and this with the help of rule 2. Okay, so you just write this in this form: 4d plus 4 x square plus d square minus 4d plus 4 sine 2 x. Okay, so no need to write sine 2x here, and no need of this bracket, no need of this plus. Yes, plus we needed. Okay, so d square minus 4d plus 4 sine 2x. Now 1 by 4 1 plus d square minus 4d divided by 4 minus inverse x square. Okay, sorry, minus 1, not minus inverse, minus 1 or inverse, plus here you see now we can solve it by using rule 2. Okay, in rule 2 we do what? We replace d square by minus a square. So here a is 2, so d square will be replaced here by minus 2 square, that is minus 4. Okay, so instead of d square we are going to write 4, right? So minus 4 minus 4d plus 4. Okay, sine 2x. So this sorry, this is not d is not here, right? So 4 and 4 cancel, we are left with minus 1 over 4d only. Now it would be equal to 1 over 4 1 plus d square minus 4d plus 4 plus d square minus 4d divided by 4 whole square up to so on. Okay, so see, अब यहाँ पे x square का पावर कितना है? 2 है, सो d square का पावर 2 होगा तो डिफरेंशिएशन कितनी आ जाएगी? 2 आ जाएगी. अगर इससे ज़्यादा होगा तो हायर देन दिस विल बी मेकिंग इट 0. ओके, सो वी नीड द पावर अप टू 2 ओनली. तो कहाँ तक पावर चाहिए हमें? 2 तक ही चाहिए इसकी. तो जो भी हायर पावर होगी उनको आप अब नेग्लेक्ट कर सकते हो, राइट? सो माइनस हियर यहाँ पे क्या है? एक्स स्क्वायर प्लस 1 over minus 4d sine 2x. So if you write this you can write this in taking minus outside, okay, and you will be left with this thing, okay. So we know this means this 1 by d means integration. So in next step we would be integrating sine to x with respect to x. So here you see 1 over 4, 1 प्लस यहाँ पे कितना आ जाएगा डी स्क्वेयर बाय 4 माइनस 4d/4, इट वुड बी d ओनली. अब देखिए यहाँ पे कितनी पावर आ जाएगी, 3 टर्म आएंगी. फर्स्ट टर्म वुड बी d4, तो d4 के साथ डी स्क्वेयर की डिफ्रेंशिएशन कितनी हो रही है, 0 हो रही है, तो नो नीड टू राइट दिस, राइट. सेकेंडली यू सी और क्या आएगा यहाँ पे, वन मोर टर्म वुड बी डी क्यूब, ओके. सो डी क्यूब के साथ भी डी एक्स स्क्वेयर की डिफ्रेंशिएशन 0 हो जाएगी, नो नीड टू राइट दैट, ओके. वी ओनली नीड टू राइट 16 डी स्क्वेयर डिवाइडेड बाय 4, एक टर्म ये आएगी यहाँ पे, ठीक है. सो वी जस्ट नीड टू राइट दैट थिंग ओनली, ओके. एक्चुअली ये होता कितना है देखो, इट वुड बी इक्वल टू, इट वुड हैव बीन इक्वल टू, ओके लेट मी राइट इट हियर, ओके, बाद में कर लेंगे ये 0. सो इट इज d4 अपॉन 16 माइनस 8 डी क्यूब अपॉन 16 प्लस 16 डी स्क्वेयर divided by 16 using the basic formula a plus b whole square, okay. so plus so on x square, और यहाँ ये कितना होगा minus 1 over 4 integration of sin 2x, integration of sin 2x is minus cos 2x divided by 2 because 2 is here, so it would be divided by 2, so total कितना हो जाएगा minus 1 by 8 cos 2x, right. Now next, so it is equal to 1 by 4 x square. यहाँ पे जब आएगा तो डिफरेंशिएशन कितना हो जाएगा, 2 होना था, और 2 by 4 कितना हो जाएगा 1 by 2, और ये माइनस 2x, और ये प्लस 0, माइनस 0 प्लस 16 by 16 2 कैंसिल, एंड डी स्क्वेयर एक्स स्क्वेयर कितना आ जाएगा 2 आ जाएगा, प्लस 0 0 0, ओके. सो क्लोज इट हियर एंड प्लस दिस इज इक्वल टू 1 by 8 cos 2x, right. So in this way we get the particular solution which is equal to, okay देखिए which is equal to 1 by 4 x square minus 2x and half and 2, it is equal to 3 by 5 by 2, 5 by 2 plus okay. So next would be 1 over 8 into cos 2x. हमने एक सिल्ली सी मिस्टेक कर ली है इसमें, सो यू जस्ट करेक्ट दिस. वी नो बाइनोमियल एक्सपेंशन, ओके. इसमें होना क्या था, इट वाज -1 here and +1 was here, right. So it would be alternate sign, it would be minus, it would be plus, okay. So we wrote it plus, this would be negative and this would be addition, okay. So in this way this is negative and this is positive, so it is positive, and so it would be 3 by 2, okay fine, plus 1 by 8 cos 2x. So in this way if you take minus 1 over 8 common from both the side, you get inside 2x square plus 4x plus 3 plus cos 2x. So this is the particular integral. So total solution or complete solution y is equal to yc plus yp. So yc is equal to c1 e raised to power x 2x plus c2 x e raised to power 2x plus particular solution is 1 by 8 2x square plus 4x plus 3 plus cos 2x. So this is the required solution of given differential equation. So in this way we can solve this problem, right? You just solve one more problem. Okay, this is an exercise for you. Solve y double dash minus y single dash plus 4y equal to 8 times x square plus e 2x plus sine 2x. Okay, this is an exercise for you. So with this we end today's lecture here. Rest of the things will be done tomorrow. Thank you.